All right, this is section 6.3, separation of variables. So separation of variables, if we have a function in the form m of x plus n of y dy dx equals 0, m is a continuous function of x and n is a continuous function of y. If we group all the x terms on one side with the dx and all the y terms on the other side of the equation with dy, we can find a solution using integration by a method called separation of variables. So let's look at that. Essentially, we want to take our equation, our original equation, and rewrite it so all the x's and dx are on one side and all the y's and dy are on the other. Well, in this first one, I could subtract an x squared over, leaving me 3y dy dx equals negative x squared. Well, now I want to get the dx over to the other side, and remember, we can just essentially multiply that over. So we have 3y dy equals negative x squared dx, and now it is rewritten. Next one here, we're going to divide by sine of x. Remember that y prime is the same thing as dy dx. Cosine over sine is cotangent of x. Now we do the same thing with our dx, get it over to the other side. So dy equals cotangent of x dx. And this one, the only thing we need to really move here is that x. We want to divide by x on both sides. Remember that y prime is dy dx. And I would actually rewrite this as 1 over e to the y plus 1 equals 2 divided by x. Now we just move that dx over. And we have 1 over e to the y plus 1 dy equals 2 over x dx. So now we're going to use that to find a general solution. So step 1 is get all the x's on one side, all the y's on the other. So I would divide both sides by x squared plus 4. And then I get dy dx equals xy over x squared plus 4. Well, I don't want that y on the right side. I'll divide that y out. Gives me 1 over y dy dx equals x over x squared plus 4. Well, I got to get that dx over to the other side. Multiply that on over. And I have 1 over y dy equals x over x squared plus 4 dx. And now is the point where I'm actually going to do the calculus portion. I'm going to find the indefinite integral. Well, the antiderivative of 1 over y is ln of the absolute value of y. For the x's, we have to get a little creative. We have to use u substitution. If u is x squared plus 4, then du is 2x dx, which means we'll stick a 1/2 out front, antiderivative of 1 over u du. All right, so that means the natural log of the absolute value of y is equal to 1/2 times the natural log of the absolute value of u plus c. We'll plug u back in, well, x back in for u. 1/2 natural log of the absolute value of x squared plus 4 plus c. Now, we would not generally leave this like that. Remember that a 1/2 power, or a 1/2 out front, can become a power inside a logarithm. So we have natural log of the absolute value of y equals natural log. A 1/2 power is a square root x squared plus 4 plus c. A square root's always positive, so we don't have to worry about the absolute values anymore. Also, x squared plus 4 for any real number is positive also. Now, to undo a natural log, we take both sides and we make them the power on an e. So we raise e to each of those sides. E to the natural log of y is just y. Also remember, we can split these apart. We can make it e to the natural log of the square root of x squared plus 4 times e to the c power. Well, e to the c power, that's just some other constant. So y equals some constant times e to the natural log of something, cancels each other out, so the square root of x squared plus 4. Now the question might be, why did we drop the absolute value from right here on the y? Well, our c value could be positive or negative, so that really makes that absolute value unimportant because c is going to absorb that positive or negative situation for us. All right, we have an initial condition this time. Y0 equals 1. We'll find the particular solution of this equation. We want to start by getting our x's and dx on one side, our y's and dy on the other. So I personally would subtract xy dx over to the other side. Oops, xy dx. So e to the negative x squared power times y squared minus 1 dy equals negative xy dx. I'm going to get my x's on the right, so I'm going to divide by e to the negative x squared. Gives me y squared minus 1 dy equals negative xy over e to the negative x squared dx. Uh-oh, I don't want that y on the right, so I'll divide that over. Y squared minus 1 divided by y makes y minus 1 over y dy. Negative x over e to the negative x squared. I can bump that up to the top and make it e to the positive x squared dx. And now we take the antiderivatives. The antiderivative of y is y squared over 2. The antiderivative of 1 over y is natural log of y, absolute value of y. Over here we want to use a little u substitution. If u is x squared, then du is 2x dx, which means we have negative 1/2 antiderivative of e to the u du. So I have y squared over 2 minus natural log of the absolute value of y equals negative 1/2 e to the u power. I'm just going to plug x squared right back in, plus c. Now we're not done. Obviously it doesn't look super pretty, but this one's not going to get much nicer than that. But we have that initial condition, y0 equals 1, y of 0, sorry. So y of 0 equals 1, that means y is 1, and x was 0. So 1 squared over 2 is a 1/2, minus natural log of 1 is 0, negative 1/2 times e to the 0 power is 1 plus c. I have 1/2 equals negative 1/2 plus c. So c must equal 1. So we have our particular solution now. Go back up to where we had our equation and plug in c is 1. So we have y squared over 2 minus natural log of the absolute value of y equals negative 1/2 e to the x squared power plus 1. You might also see everything multiplied by 2 to make it y squared minus a 2 out front of a natural log becomes ln of y squared equals negative e to the x squared power plus 2. And they might even add that e to the x squared power over to the left side. Any of those options work just fine. There we go. Now we want the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. If it tells you it has a slope, that's your dy dx. And to find the antiderivative, we want to divide by y. Oh, over here, there we go. And then multiply that dx over. So I have 1 over y dy equals 1 over x squared dx. And we'll find our antiderivatives. The antiderivative of 1 over y dy is natural log of the absolute value of y. The antiderivative of 1 over x squared dx is negative 1 over x plus c. And as before, we will make that a power on an e to get rid of that natural log. So y equals e to the negative 1 over x times e to the c. All right, y equals c e to the negative 1 over x power. But wait, there's more. This problem gave me an initial condition, the point 1, 3. So 3 is y, x is 1. So that means 3 equals c times e to the negative first power, which means I will divide by e to the negative first power, which is multiplying by e. C is 3e. All right, then I will plug that right on back in. Y equals 3e times e to the negative 1 over x power. You might also see this combined into something like this, 3e to the x minus 1 over x power. Either of those, totally fine. They just took the exponents, 1 plus negative 1 over x, got a common denominator to make it x minus 1 over x. That would be okay, no worries. And a word problem. The rate of change of the number of coyotes, n of t, in a population is directly proportional to 650 minus n of t, where t is time in years. When t is 0, the population is 300, and when t is 2, the population is 500. Find the population when t is 3. So if the population is directly proportional to, the rate of change of the population is directly proportional to this, that's a fancy way of saying dy dt equals k times 650 minus y. And we know how to integrate that. We divide by the 650 minus y. We'd multiply that dt. We have 1 over 650 minus y dy equals k dt. Antiderive. We get negative ln, the absolute value of 650 minus y, equals kt plus c. All right, that negative, different things we could do with it. I would just divide everything by negative 1. And having a minus c really makes no difference because whatever c is can change, so I keep it plus. All right, to get rid of the ln, we do e to a power. So we get 650 minus y equals e to the negative kt times e to the c. So 650 minus y is c e to the negative kt power. Subtract that 650. Negative y equals c e to the negative kt minus 650. And divide by negative 1 yet again. Y equals negative c e to the negative kt power plus 650. Now there's no need for me to make this c a negative because I don't know what c is. It might just be a negative number. So I always just keep it as c. All right, now we get our initial conditions out. When t is 0, the population is 300. Now this one's not quite as simple as c is 300. So, go up on the side here. When t is 0, y is 300. 300 equals c e to the negative k times 0 plus 650. We subtract 650. C times e to the 0 power is 1. C is negative 350. There we go. Now we take our other condition. When t is 2, the population is 500. So 500 equals, c is now negative 350, e to the negative k times 2 plus 650. And now we solve for k. We get negative 150 equals negative 350 e to the negative 2k power. Divide by negative 350. I get 3/7 equals e to the negative 2k. Take a natural log. It's negative 2k. Divide by negative 2. And k is approximately, I realize this isn't the exact number because I'm going to have to round, 0.424. All right, and now I can finally answer my question. What is the population when t is 3? Well, y equals, c was negative 350 e to the negative k times t, which is 3, plus 650. I'm just going to type that in my calculator because that's miserable to try to do anything by hand. I also use the answer key for 0.424 instead of actually typing that number in because it'll be more exact. I got 551.802. Now, depending on which way you're going with this, We can't have 0.8 of a wolf. So I would probably round it to 552 wolves. Or coyotes, my goodness. Apparently I'm upgrading them. Some people might just drop that 0.8 and call it 551 coyotes. All right, so now your assignments, page 429, 5 through 20, all.